when it comes to the inlets and outlets of rotating equipment, okay, the higher pressure side is going to be smaller. I don't want y'all learning it by, oh, a pump's outlet is smaller, compressor's outlet is smaller, turbine outlet is bigger. I don't want y'all learning it like that because you're going to get them backwards. Learn it as the higher pressure side is smaller, okay? So the purpose of a pump is to move liquids, and in order to have flow, movement, you have to have a difference in pressure. So if it boosts the pressure of a liquid in order to move it, okay? So this is a centrifugal pump. It's gonna use centrifugal, we're gonna learn about all that, but pretty much you see the impeller spinning? You see this thing, if I move this, it spins. Think anatomy, the long stick, it's the shaft, okay? Does that help? It's inappropriate, but does it help? Yeah, all right. If I rotate the shaft, my pump spins, right? So, boat motor, think about the impeller on a boat. The faster it spins, the faster you go, right? So the impeller is gonna increase the speed of the liquid, and then when it's forced through the smaller pipe diameter, it's gonna convert that speed to pressure. Increase the pressure, okay? So, the purpose of a pump is to increase the pressure, right? Alright, so would the inlet or the outlet be smaller? So smaller pipe diameter equals higher pressure, right? Mm-hmm. Think of a little pew-pew bottle cap gun. You know, you did that and smack somebody in like middle school maybe? Mm-hmm. Flow in or out, right? This is a flow in or out. When you make that little pew-pew with the water bottle cap, to compress or to make higher pressure, right, you make it take up smaller volume. Mm-hmm. We know we can't compress a liquid. This is just my trick to. They're technically out of class. They decided to say so I can show them something. Okay? The purpose of a pump is to increase the what? Pressure. Of a
liquid.
Okay. So higher pressure. Remember that. Think about that bottle cap. Smaller to increase the pressure to make that cap fly, right? So higher pressure, is it going to be smaller or larger pipe diameter?
Smaller.
Smaller. Okay. Purpose of a pump is to
increase the pressure.
Increase the pressure. So is the inlet or the outlet going to be smaller? Out of A and B, which one's the outlet?
B.
Make sense? Yep. Okay. Compressor, a centrifugal compressor. This is the best we got. It's going to work the same way, except can you compress a liquid? Can I make this much liquid take up this much space?
No.
No, I can't do it. It's impossible. I can't take a full water bottle and make it only take up half the water bottle, right? Without pouring it out. So pumps are for liquids. Compressors, you can compress a vapor, or for vapors. If a centrifugal compressor is going to work the same way. It's going to have a shaft that has to spin. Compressor is going to have a shaft that has to spin. This is just a little 3D printed model, so I can't make it spin. These are going to spin, increase the speed of the gas, and then force it through these little channels. And then when it goes through those little channels, it converts that speed to pressure. Same concept, right? Okay, now a turbine, on the other hand. What makes a wind turbine turn?
Wind.
Yeah. What makes a steam turbine turn? Just based on what you know about a wind turbine. So y'all will never, please don't ever be that fourth semester student. When I first started, my first semester, 50%, if not more, of my fourth semester students were telling me a steam turbine turns water into steam. And second semester, I came up with a rebuttal. Does a wind turbine turn air into wind? Is that its job? You realize how stupid that sounds when you correlate it with something you know? Okay, so wind turbine is turned by
wind.
Steam turbine is turned by
steam.
All right, what do y'all think turns a gas turbine? Gas. So it's actually the combustion from the gas. But that's how all our vehicles work. Yeah. Okay, so steam's going to come in, and it's going to hit these buckets, or chevrons, whatever you want to call them. It's going to force this to turn. Now remember that male anatomy thing? What else is turning?
The shaft.
The shaft. Okay. Give me that rolly cart right there. people that didn't play football, y'all familiar with sled runs and what they are? Okay, no? Okay, so they had to push this big heavy thing on the football field when they got in trouble, up and down, right? I don't know, it's like this tall and you gotta just use your weight. It's usually for like your wide receivers and stuff.
Lineman.
Linemen. I'm learning football. I'm trying. My husband's. Anyway. Alright, so let's say you got in trouble for being inappropriate at school or something, and your coach makes you do 15 sled runs, okay? Drink a couple Red Bulls to give yourself some wings, and you start off. Is the same amount of pressure that you're able to put on the first one, are you going to be able to put that same amount on the 15th?
No.
Why? You're using your what? Your energy? We need to be able to exert a lot of the pressure to be able to make this thing turn, right? And some of these are bigger than this classroom, okay? Some are little, but it just depends on what it's being used to make rotate, okay? So we need high pressure to make this rotate, right?
Mm-hmm.
Okay, well, the same thing's happening with the steam as that is happening with you when you do a sled run. Using high pressure steam, it's using its energy to force this to rotate, which is forcing the shaft to rotate, right? So what's going to happen to its pressure if its energy is being used? It's going to lower. So out of these two, which would be your inlet? Which would be your outlet? A turbine's job is not to increase the pressure of the steam, is it? No. A wind turbine does not make the wind blow faster, right? So let's go here real quick. In a vehicle, who makes the wheels turn? Is it the baby in the back seat? Is it the wife that's a backseat driver? Guilty. Is it them? No, who is it? The
Driver.
Driver. Okay, so remember that pump right here? The shaft right here, did you show this in it?
Mm.
The shaft right here, if I rotate the shaft, I rotate the pump, and now we have a pump that works, right? A driver is whatever's connected to this pump to rotate the shaft, okay? So that could be an electric motor, but if you're already using steam to heat stuff, why not also use that steam and save yourself on electricity at the plants? Because we know millionaires are stingy. So when this is rotating, what's rotating?
Shaft.
Okay, now y'all have to excuse the size difference. Normally these shafts are sized the same, okay? This shaft would be connected with a coupling. Let me see. I'm missing a couple pieces, so I'll show y'all that when we get to pumps in section 3, or rotating equipment. That shaft is gonna be the same size as this one, fatness, right? And then we'll use a coupling to attach the two. And so that is our driver. Our driver is what makes our pump rotate, or our compressor rotate, or a generator rotate, okay? So you have electric motors that could be drivers, you have gas turbines, you have wind turbines that the way they make electricity is the wind turns them and they go to a generator. And that generator is wired to go, right? Assume they're the same size, because that doesn't really matter. If I have a T, that's your turbine. If I have a C, that's your compressor, okay? They look the same? Yeah? Can you see the board? Mm-hmm. They look the same? Yes. Your turbine, your compressor? And you can draw it facing this way or that way. It doesn't matter. The reason I drew them both is because your shaft is going to, y'all know what the shaft is now, right? It'll be connected to connect what it's driving, okay? So you never put your arrows here or here. You put your arrows here or here, okay? And you can have both arrows on the top or both arrows on the bottom, or however you want to do it. You can flip them this way or that way. It's mainly your arrow placement going in and coming out.
So they're always connected?
No. A turbine could be driving a pump.
Okay.
Or an electric motor could be driving a compressor. But I just wanted to show y'all that the inlet and outlet is not going to be here, because that's where the shaft would be if it's a turbine. Okay? So I'm going to go ahead and erase this, because that's not how I'm wanting y'all to draw it. I just wanted y'all to see that. Okay. These are your flow areas. So a turbine, where's your higher pressure?
Going in the top.
Going in or coming out?
Going out. On a turbine?
What's the purpose of a turbine? Does it increase the pressure of steam?
No.
Mm-mm. what's it do? It drives rotating equipment. To use that energy, it's going to do what to its pressure?
Lower it.
Lower.
Yeah, if you use your energy on that sled run, what's going to happen to the pressure you're able to exert on it?
It's gonna
Diminish.
So a turbine, we're going to send high pressure steam. So your arrow could either be down here or up here. Either way, I don't care. It's both right, and this could be facing this way or that way. All I want is your inlet arrow, not here or here, but going into the smaller diameter, okay? And then your outlet, it could be up here or down here, doesn't matter. I just want it being on the fatter side, okay? Because it's losing energy. And now you can be up next to a turbine or a compressor or a pump, and you're gonna always know where its inlet compared to its outlet is. You're gonna know which is which. Okay, your compressor on the handle, what's its purpose? It what?
Compresses it.
It compresses
So it
what?
increases
Vapor?
pressure.
Vapor? Or
Air.
gas?
Yeah.
Okay, and in order to do that, you gotta increase the,
Pressure.
okay, so is it gonna come, higher pressure is gonna be what, smaller or bigger?
Exiting.
Smaller?
Small.
Smaller? Okay,
So
so
it's
is your
gonna exit.
outlet gonna be smaller or bigger?
Smaller.
Outlet smaller.
So I'll do it up here just so it don't blend with this too much. Out. And you can do it like this even. It doesn't matter, just as long as the arrows are on the skinny side and the fat side. So does that make sense? Do you see the difference of them? Same symbol, it's just where you're entering and exiting on small or big side is what's going to be different. So if you do this, can I clear it real quick? We good? If you do this, does that tell me anything?
No.
Do I know if it's a turbine or compressor?
No.
That's not worth anything on pump list. All right? Yeah, like well, what's the difference of your turbine and compressor if you draw that to both of them, or only one of them? That's -5 for each question, right? Okay, good.